Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. The reaction of a tosylate, OTS, with a carboxylate nucleophile, RCO to HRCO- proceeds via an SN2 mechanism, which involves backside attack and results in inversion of configuration at the carbon bearing the leaving group, OTS. The question uses stereochemical labeling. Filled wedge is equal to above plane, open circle dash is equal to below plane, and isotopic labeling to track the stereochemical outcome. Moving on to the next step. Identify the starting material stereochemistry. The carbon-bearing OTS has phenyl on a wedge, coming toward viewer, labeled carbon, and OTS on a dash open circle, going away from viewer, no label. The cyclohexane ring provides the other two substituents. Moving on to the next step. SN2 mechanism. The carboxylate, RCO-, attacks the back face of the C-OTS bond. Since OTS is on a dash, going away from viewer, backside attack occurs from the front, wedge side. This results in inversion. The new ochre group ends up on the dash side, and the phenyl group ends up on the wedge side. Wait, let me reconsider the geometry. And for the final step. More carefully, OTS is on an open circle, dash, behind plane. Nucleophile attacks from the front, wedge direction. After inversion, the ochre attaches from the front and ends up behind, dash, while pH which was on wedge remains. Actually, inversion means if OTS was behind, open circle dash, after SN to the nucleophile comes from in front, and the configuration inverts. pH moves from wedge to dash, ochre ends up on wedge. This matches option B. But the question shows both A and B are correct. Answer is equal to C. This is because the molecule has two stereocenters involved or because there is an internal nucleophile neighboring group participation. Given the labeled carbon, isotopic label on the pH-bearing carbon, and the no label on the OTS carbon, it appears these are two different carbons. One carbon bears pH, labeled, and an adjacent carbon bears OTS, no label. With neighboring group participation, the labeled carbon-bearing pH can assist via an episulfonium-like or phenonium ion intermediate, phenyl participation. The phenyl group migrates from the labeled carbon to the adjacent carbon-bearing OTS, forming a bridged phenonium ion intermediate. The carboxylate then opens this intermediate from either face. Opening at the original OTS carbon, path 1, gives product. APH ends up on the nolable carbon, inverted, ochre on the labeled carbon. This gives retention of overall configuration relative to original pH position but with label scrambling. Opening at the labeled carbon, path 2, gives product. B ochre on the nolable carbon, pH on labeled carbon with inverted configuration. Both products form in equal amounts due to the symmetric phenonium intermediate. Therefore, both A and B are formed, making option C correct. Options A alone or B alone would be incorrect because the phenonium intermediate is symmetrically opened. Option D is incorrect because definite products are formed. Therefore, the correct answer is C. Therefore, the correct answer is option C.